Now that we have a good understanding of permutations and combinations, today what we're going to do is to learn how to find the number of permutations and combinations for a given set. Recall that with permutations, order matters, and with combination, order does not matter. The number of permutations of r things from a set of n is given by n factorial all over n minus r factorial. This is sometimes denoted by NPR. For instance, we could say, how many ways can a club with 10 members select a president, vice president, and a secretary? Well, if we assume that they can't have multiple positions, we could actually use our old mathematics to say, well, there's 10 ways to choose a president, 9 ways to choose a secretary, or 9 ways to choose the vice president, and 8 ways to choose the secretary. Here we see, with our old counting techniques, because you cannot repeat positions, there would be 10 times 9 times 8. However, we can actually use our formula for permutations because order matters. The first position is president, second is vice president, and the third is secretary. That would give us a different club with a vice president, president, and secretary if we change the order. So, recognizing that this is a permutation where we have 10 people and we're arranging 3 of them, this would be 10 factorial all over 10 minus 3 factorial. That's also known as 10 factorial over 7 factorial. We can write out the numbers and cancel the 7 times 6 times 5 times 4 times 3 times 2 times 1 in both the top and the bottom, and we're simply left with 10 times 9 times 8, which is 720. And again, we're seeing that 10 times 9 times 8 that appeared before. So this really isn't anything new for us. The number of combinations, or if you will, subsets, from a set of n things is given by n factorial all over r factorial times n minus r factorial. This is sometimes denoted by NCR. This is similar to the formula for permutations, except we have an extra r factorial in the denominator. Alright, here's a question. How many ways can a club with 10 members choose a committee of 3 members? If we choose a committee, it doesn't matter the order in which we choose the members. For instance, I could choose a committee with person 1, 2, and 3, but this would be the same thing as the committee with person 3, 2, and 1. The order doesn't matter. So, we apply our formula for our combinations, and we have 10, because we have a total of 10 people, of which we're choosing 3. So this will be 10 factorial all over 3 factorial times 7 factorial, which gives us the 10 times 9 times 8 all over 3 times 2 times 1. Again, we've simplified this by crossing off the 7 times 6 times 5 times 4 times 3 times 2 times 1 that appears in both the top and the bottom. We can simplify this by recognizing that 9 divided by 3 is 3, and 10 divided by 2 is 5. So we really have 5 times 3 times 8, which gives us 120. Here's another problem that might seem familiar, because this deals with sets. I could ask, how many subsets of cardinality 3 can be made from a set with cardinality 4? Now, we're dealing with subsets, so you might say that there are 2 to the 4 subsets. And that's certainly true because of our formula for counting subsets. But we're not interested in the number of total subsets, we're interested in the number of subsets with cardinality 3. With sets, the order doesn't matter, and so this turns out to be a combination problem. We want to find 4, choose 3. In other words, we have 4 elements and we want to choose 3 of them. So we have 4 factorial all over 3 factorial times 4 minus 3 factorial. That gives us 4 times 3 times 2 times 1 all over 1 factorial times 3 times 2 times 1, or if you will, that gives us 4, because 1 factorial is 1. Going back to this idea of all the sets versus sets with cardinality 3, or all of the subsets, we can actually list them out because we know that there are going to be 16 subsets. We have the empty set with cardinality 0. We have 4 sets with cardinality 1. We have 6 sets with cardinality 2. We have 4 sets with cardinality 3. And we have 1 set with cardinality 4. We are looking for the sets with cardinality 3. Alright, so what I want you to notice, which will lead into next class's lecture, is the symmetry that we have here. There's one set or one subset with cardinality 0 and 4, and then we have sets with cardinality 1 and 3. There are 4 of them, and in the middle we have 6 sets with cardinality 2. So in a way, we could write this as 1, 4, 6, 4, and 1. The numbers tend to increase, and then they start to decrease.